to make things rounded.
Okay.
So I make a cup, I cut out the side, it's a rectangle, lay it on here, bend it around until I get the diameter I want it to be.
Okay.
This is a box steak or anvil steak. I can pound something flat on this or bend over the edge of it.
How do you keep the pieces together?
This is a hatchet steak. It's been a straight line. I can solder, or I can rivet, or I can bend. So soldering is now, this is a heat source. I was soldering, but now I burned charcoal in here, and I got so much ash in here now I can't get the soldering coppers hot enough. This is soldering copper. I also call it soldering irons. This end piece is a solid piece of copper. So to solder, I put this into the hot coals. I put a flux on the seam I want to solder. Say this bottom. So you put a flux on here. Traditional fluxes are things like pine tree sap or a mixture of tallow and beeswax. Right, so you put the flux on here, you take the hot copper out, you stick it in a container of water and flux. This is water. You stick it in the container of water and flux, clean it off because it's going to get ash in the charcoal. Just enough to clear off the tip, because that's all I soldered with, just the very end. So I stick it in there, get the ash off. Also, when I stick it in the water, it tells me if it's hot enough. It just sizzles, it's not hot enough. I want to hear a psh.
Got it.
So if it's hot enough, I didn't touch it for the solder, get a little ball, melted solder, and just pull it along the seam. And the flux, along with gravity, helps the molten solder flow down into the crack. Now, traditional solder would be 50% tin, 50% lead. We kind of frown on that nowadays. So modern tinsmiths use leadless solder, which is mainly tin, 95 to 100% tin. So I can also rivet together. This handle here on this dustpan is riveted on. So a tinner's rivet looks like this. So to rivet two pieces together, you punch holes into both pieces. We use punches instead because it's easier to punch sheet metal than it is to drill it. Punch the holes in it. Put the rivet through the holes. Put it down on a hard surface. Get a riveting hammer and just pound on that stud. Knock it down. We don't flatten it down. You knock it down to about a quarter of its original height, so you're more like you're mushrooming out. You take this finishing tool, see that dome shape there. You place that on it. Hit it with a bigger hammer. And that finishes the riveting job. So there's the base of the original rivet. And then there's the part that's been pounded on. Finished off the dome tool.
Wow, that's great.
So this candle holder, the handle and the socket are made with tabs that are pushed through slits cut into the base. So this is made without any soldering or any riveting. So that's the three ways you can join things together.
That is interesting.
So the stakes are used to shape, and there are about 20 common stakes. So this is just a sampling of stakes. Then prior to 1800, all work was done using just the stakes. But in 1800, they started making machines. So by the time of the Civil War in the 1860s, the machines are pretty common. So this is a wiring machine. It's used to install wires, like this cup here. It has a wire in the lip. The tin's wrapped around the wire, and there's wires here in the handle. Okay, so install a wire. You start out by, this is a handle, you turn the edge up 90 degrees, you lay the wire inside the angle. You hold the wire in place with these duck-bill pliers. You take a wooden hammer and you knock the tin over the wire. So you just move down and knock the tin over the wire. So you do that, it ends up looking like this. So the tin's on the wire, but it's not really wrapped around, it's got ding marks in it from when you get up the hammer. So you want to smooth that out. Now a traditional way to do that would be with this creasing stake. So you lay the wire sight down, the appropriate size groove, and just drive it into the groove. And that wraps it around and smooths it out. I have a modern tinsmith, I don't need that. So I have a wiring machine. So I just take that rough looking piece I showed you, stick it in the machine, and then crank it through, and then it wraps it around, smooths it all out. So I have another machine. It's called a burring machine. And it's used to make bottoms. So all cylinder shapes have the same type of bottom. So the bottom is a disc with a turned up edge. Alright, so everything has to start flat, so you start with a flat disc. You stick it in the machine between the two wheels. You tighten down on it so it sits there like this. Then you crank the handle. and it rotates it and it bends it a little bit, but doesn't bend at 90 degrees. To get the 90-degree bend, you need to lift it while it's rotating.
Okay, got it. I see.
And then you solder that on. Most tinsmithing machines, at least until, well, I don't know until when, but in my time period, almost all of them are made in Connecticut somewhere.
Okay.
A lot of them are made in Berlin, Connecticut.
Okay. Amazing, thank you.
You're welcome.
Thanks for your demo.